Howdy, I'm Jeff. I'm an engineer on the MapKit team, and I'm excited to introduce you to MapKit for SwiftUI. With our greatly expanded SwiftUI API, it's easier than ever to integrate maps into your apps across all platforms. We think you're going to love using MapKit for SwiftUI to create powerful mapping experiences for your users. To show you how easy it is, I'll build a fully functional trip planner from scratch. I'll walk you through every step, and we'll be done before the end of this session. My family is headed back home to New England this weekend, and we'll spend Saturday exploring the beautiful city of Boston. We'll walk through the city in the morning and see the sights, we'll have lunch in the historic North End, and probably grab a cannoli for dessert. The weather's looking perfect too, so we'll head out to the beach in the afternoon and feel the sand between our toes. It's going to be a lot of fun. I'll build an app to help us plan the day. I'll use annotations to mark places on the map. I'll enable selection so that I can tap on each marker to learn more about that place. I'll integrate Look Around to explore some places we might want to visit. I'll add an overlay that shows a driving route to the beach. I'll use the map to display different locations and regions. I'll add another dimension to the map by enabling realistic elevation. I'll show you how to display satellite and flyover imagery as well. I'll add some controls to the map, including a user location button so that I can figure out where I am. We have a lot to cover. Let's get right into it. I'll start with a brand new SwiftUI project. I'll be using MapKit, and I'll add a map. Nice! I have an interactive map with just one line of code. My family will start the day by driving into the city and parking so we can walk around. I've heard it said there's a particular place you should park your car near Boston, but I like the parking garage right underneath the Common. Boston Common is a beautiful park right in the middle of everything, and it'll make a fantastic starting point for our walking tour. The first thing I'll do is add some content to the map to mark the parking garage. I'll mark the spot right above the ramps that vehicles use to access the garage, near the elevator we'll ride up to start walking. You'll learn about using marker and annotation to display content at a specific coordinate on the map. So, let's park the car and start walking. I'll use a Map Content Builder closure to add a marker to the map. Cool! If you're familiar with SwiftUI, adding a marker to the map feels a lot like adding a view to a list. Check out how the map has automatically framed our content by zooming in to show the marker. So, what's a marker? Are there other types of content that I can present using the Content Builder? Markers are used to display content at a specific coordinate on the map. The balloon shape might look familiar to you. You'll find markers used in the Maps app and across the platform, including in a wide variety of apps you can find on the App Store. Like marker, annotation is used to display content at a specific coordinate. Instead of marker's balloon, annotation displays a SwiftUI view. The Content Builder can be used to present overlay content as well. You'll learn more about these a bit later. For now, all you really need to know is that you can use the Content Builder closure to add all kinds of content to the map. I want to display a custom SwiftUI view for the parking spot, so I'll use an annotation to mark it. Here, I'm using ZStack to compose some shapes in an image. This SwiftUI view will be displayed on the map centered right on the parking coordinate. If you'd like your view to be positioned above the coordinate instead, you can use annotation's anchor parameter. Specifying an anchor value of bottom will position the bottom of your view right on the annotation's coordinate. Alright, the app marks where we'll start our walking tour. I've used a Map Content Builder to display annotation content on the map. Next, I'd like this app to convey a sense of place as I'm looking at the map. I'll use Map Style to achieve that by enabling realistic terrain elevation. You'll learn how to use Map Style to display satellite or flyover imagery as well. You can set a style using the Map Style modifier. This is the standard map style. By default, it offers a flat presentation, much like a physical paper map. It looks like there's a bridge across the lagoon, so you can walk from one side to the other. This flat map really leaves something to the imagination, though. I'll enable realistic elevated terrain to give the map another dimension to work with. Enabling realistic elevation really brings the map to life. Looking at the lagoon now, I can imagine taking a ride on one of the swan boats that cruise around in the summer and picture the boat passing under the bridge. Using the imagery map style is another great way to offer your users a sense of place. The imagery map style displays a map rendered using satellite or flyover imagery. The hybrid map style combines imagery with roads and labels. To recap, I've enabled realistic elevation using the standard map style, and I've shown you how to use some other map styles as well. Next, I'd like the app to help us search for the places we want to visit. Our kids will be with us walking around Boston, and I want our morning to be fun for them too. The grown-ups can appreciate seeing some history, while the kids can appreciate swings and slides and monkey bars. I'll add a button to search for playgrounds and a button to search for beaches too. The app will add a marker for each search result. You'll learn a little bit more about markers, and you'll also learn how to show your own UI above the map without getting in the way of the search results. Earlier today, I made a little Beantown Buttons view. Tapping a button calls a search function with a simple query, either playground or beach. The search function uses mkLocalSearch to find places near the Boston Common parking garage and writes the results using a binding. Back in the app's main content view, I'll add state to keep track of the search results. When the Beantown Buttons UI performs a search, it will write the results back to this state using a binding. I'll add the buttons above the map at the bottom of the screen. Using Safe Area Inset will make sure the app's UI doesn't obscure any of the content I'm adding or any system-provided controls that can appear on the map, such as the Apple Maps logo and legal link. Next, I'll use the Content Builder to add search result markers. I'm using ForEach to add a marker for each search result. I'll try these buttons out. Let's find some playgrounds. Look, playgrounds! The map has automatically framed them by zooming out so that all of them are visible. How about some beaches? The search results are MK map items, which is the type MapKit APIs like mkLocalSearch use to represent places. Here, I'm using Marker's map item initializer. Markers created this way use the map item's name for their title and use information from the map item to show an icon and tint color that represent the place. Most of these search results show as light blue beach umbrella markers. When you're working with map items, Marker's automatic content and style support is very convenient. Even if you aren't using map items though, you still have control over the Marker's presentation. By default, Marker shows a map pin icon in its balloon like you see here. You can provide your own icon using an image asset or a system image. You can also show up to 3 letters of text using monogram. You can change the marker's color using the tint modifier. To recap, I've used Safe Area Inset to display some buttons above the map while making sure they don't obscure the search result markers. Next, I'm going to put the app in control of what's displayed by the map. I've been adding content to the map. Each time I have, the map has automatically framed my content for me. I'll show you how to enable this convenient behavior when you need it. I'll also show you how to display something else entirely, like the Boston area's North Shore coastline. Right now, we're looking at beaches. If I pan away and search for playgrounds, the map no longer automatically displays the results near our Boston Common parking spot. To display the search results after the user has interacted with the map, I'll need to reset the map's camera position state so that the map will frame the markers. So, I'll add state to track the position. I'll use the default automatic position that frames the content we've added to the map. and I'll pass the binding to Maps Initializer. I'll use an onChange modifier to find out when the search results are updated. When they are, I'll simply set the camera position back to automatic to make sure they're visible. Let's give it a try. I'll search for beaches, see the results, and then pan away before searching for playgrounds. Cool! Now when I perform a search, all the results are displayed even if I had panned all the way to Rhode Island. There's another thing I'd like to do using this position state. After a fun morning in Boston, my family will be driving north to spend the afternoon at the beach. I'd like the app to make it easy to see the North Shore coastline so we can get a feel for where we'll be going. I'll use the position state to do that. I'll add coordinate regions for the city and for the North Shore. I'll switch over to the Beantown Buttons UI and I'll add a binding for our position state. I'll add a couple of buttons, each setting the camera position to a region. When I press the City button, the map will show Boston. When I press the Waves button, the map will show the North Shore coastline. I'll switch back to Content View and pass a position binding to the Buttons UI. Let's give it a try. When I tapped the Waves button, the map's position was updated to show the North Shore coastline region. When I tap the City button, it's updated to show Boston. Behind the scenes, what the map shows is ultimately controlled by a map camera. The camera looks at a coordinate on the ground from a certain distance, and the orientation of the camera determines what is visible in the map. The app I'm building has not had to create or configure the camera itself. Instead, it simply specifies what should be in view using Map Camera Position. MapKit takes care of the camera for me. The app uses an automatic camera position to frame content, such as search results. It uses a region position to show Boston and the North Shore. You can specify a camera position to frame other things as well. Rect position is used to show an area, just like how we've used region. It simply uses a map rect to represent that area instead of a coordinate region. Let's take a closer look at Item, Camera, and User Location camera positions. Using MKMapItem, you can show a particular place. This works for all kinds of map items. If your map item represents Cape Cod Bay, MapKit will automatically zoom out so that it fits. If you're trying to show a certain park in the North End, the camera will zoom in to show the surroundings and deliver a sense of place. You can also simply supply a map camera configured exactly the way you want it. Using a map camera with a pitch angle is a great way to deliver a 3D perspective. Or, perhaps you'd like the camera to follow the user's location as they're walking along the Charles River. You can supply a fallback position that will be used when the user's location is not known, such as when location authorization has not been granted or while the device is trying to get a location fix. If you provide a binding to your camera position state, MapKit will update it when the camera position changes. Here's a user location camera position. The follows user location property is true. If the user pans away, the camera is no longer following the user's location. When the user interacts with the map, the camera position state is positioned by user. If the app sets the camera position state back to user location, the camera follows the user's location. When your app sets the camera position state, it is not positioned by user. The user can position the camera by interacting with the map no matter which type of camera position you specify. Alright, the app is now in control of what's in view on the map. I've used the automatic camera position to ensure the search results are visible even after the user has interacted with the map. I've used the region camera position to display Boston and the North Shore. Next up, instead of only searching near Boston Common, I'd like to pan the map to an area I'm interested in visiting and search there instead. I'll show you how to get the visible region when the camera changes. I'll add state to track the region that's visible in the map. I'll add an onMapCameraChange modifier where I'll grab the visible region from the update context and stash it in my own state. By default, the closure supplied to onMapCameraChange will be called when the user has finished interacting with the map. To have the closure called while the user is interacting with the map, you can request continuous updates by passing a frequency parameter. In addition to the region property that I'm using here, the context also has a property for the visible map rect and one for the map camera itself. Depending on my needs, I could use those as well. I'll update Beantown buttons so that it will search within the region that's visible to the user. I'll add the visible region to the buttons, and I'll use it in the search request. In Content View, I'll pass the visible region to the Buttons UI. Let's search for North Shore beaches. There's the North Shore. Show me some beaches. Sweet! How about Rhode Island? Cool! Now I can search for beaches in Rhode Island too. I've enabled this using onMapCameraChange, which informs us when there's been a change in what's visible. Next, I'd like the app to make it a little easier to pick which beach we'll be going to. There sure are a lot to choose from. To get started, I'll add support for selecting a search result. Right now, if I tap on a search result marker, nothing will happen. There's no selection state, so the markers are not selectable. To enable selection, I'll just add a selection binding to our map. Now let's see what happens when I tap on a result. The balloon animates to show that it's selected. I'm using MKMapItem as the selection type, so each marker that represents a map item is now selectable. The parking spot annotation doesn't represent a map item, so it is not selectable. If you want to support selection for markers and annotations that don't necessarily have the same type of identity, you can simply tag them. This works the same way it does when managing selection with picker and list. Here, the selected tag state is an int. Each marker is tagged with an int, so the binding enables selection for both of them. When using tag to enable selection, you can use any type conforming to hashable for your selection state. To recap, I've added a map item selection binding to map, enabling selection for the search result markers. Next, the app should display some additional information about the selected search result. I'll add a look around preview to offer a sneak peek at the beach, and I'll add the name of the beach and the drive time as well. Earlier today, when I was writing the Beantown Buttons view, I also wrote a little item info view that shows a title, the estimated travel time, and a look around preview. The look around preview will show me what the selected beach looks like. The preview displays a look around scene. You can get the scene for a given map item using MK look around scene request. The scene will be fetched when the view is displayed, and again anytime the selected search result changes. Finally, there's a property that formats an MK route's expected travel time for display using date components formatter. I'll switch back to Content View and add this item info view. First things first, I'll get a route from the parking garage to the selected search result. I'll add state to keep track of a route, and I'll add a function that uses MK directions to get one, and set the state. I'll add another onChange modifier to call the function when the selection changes. The app will show our item info view when it has a selected search result. While I'm at it, I'll hide the marker titles for the search results to clean up the appearance of the map just a bit. The item info view will display the name of the selected place instead. Okay, let's see what we got. You know, I heard there was a playground near this one. Looks pretty nice. I wonder what's over this way. Nice! A beach with a playground right there? For our family, that's going to be pretty tough to beat. It's about half an hour from Boston Common. Seems like a great spot. To recap, I've added a look-around preview that will be displayed when a marker is selected. Along with the estimated travel time from MK Route, this will really help us pick a beach. Next, since we already have a route to show the travel time, we should totally use it to display the driving route from Boston Common to the selected search result. I'll add a map polyline overlay to show the route, and I'll show you some other types of overlay content you can add as well. When a route is available, I'll add a map polyline and stroke it with blue. Let's see it on the map. Looks like a pretty nice drive. It was pretty easy to use Map Polyline with MK Route. You can also use Map Polyline to show your own location data. You can use stroke style to deliver some pretty fancy stuff, such as dashes and a gradient. If you're looking to highlight an area, you'll want to use Map Polygon or Map Circle. Here are two polygons that mark a couple of parks. Here are two circles marking the same parks. You'll notice that an overlay level is specified for each circle. The pink circle is using the default overlay level of above roads, which puts the map's labels above the circle. The cyan circle is using above labels. The app is really taking shape. I've added a map polyline to show the driving route to the beach, and I've shown you a couple of other overlay types that you can use as well. Next up, I want the app to make it really easy to figure out where I am. When we get to Boston and start walking around, it's possible, maybe even likely, that we'll get just a little bit lost. I'll add user annotation as content to show where I am, and I'll add a map user location button to find myself. You'll learn about several other types of map controls that are available to use as well. So when I'm trying to find myself, I usually start by looking for the little blue dot on the map. I've added user annotation to my map content, so now my location appears on the map. Where am I? There I am. It looks like I'm really quite far away from those playgrounds and beaches we've been checking out. I sure had to zoom out and pan a lot to get over to Apple Park. Map User Location button will sure make that easier. Now I can tap the button to display my location. The map camera will follow me as I move around. I've also added a map compass and a map scale view. The default map controls configuration shows a compass when the map is rotated and a scale indicator while the user is zooming in or out. I want these default controls in this app too, so I've specified them in addition to the user location button. I've added all of these using the map controls modifier, so the map will automatically display them in their default locations. This includes map controls on all platforms, including the map zoom stepper and map pitch slider that you'll find on macOS. If you'd prefer to position these controls yourself, you can present them in your own UI. The map controls are simply views, so instead of using the map controls modifier, you can just add them as you would any other view. When you do this, you'll need to use the map scope modifier to associate your controls with a particular map scope. We're almost at the end of our presentation, so let's summarize what we've learned today. MapKit for SwiftUI is an incredibly powerful, easy-to-use API to integrate maps into your app. It allows you to use markers, annotations, and overlays to show your content on a map. Map camera and map controls allow you to tailor the map to your needs. Finally, map style and look around give your users a real sense of place. These are just some of the features of MapKit for SwiftUI, so make sure to check out the developer documentation to learn more. And of course, because this is SwiftUI, your map will look great on all platforms. A few final thoughts as we wrap up. We've extended our Apple Maps server APIs to support autocomplete and directions. To learn more about how to use our server APIs, check out last year's Dub session, Meet Apple Maps Server APIs. As always, we'd love to hear your feedback. Please use the feedback assistant to let us hear your thoughts. Last but not least, I encourage you to check out the new features in SwiftUI this year. Animation plans are a great way to add animations to your map. Check them out in the session below. That's it! Thanks so much for watching. I'll see you at the beach.